The following figures show two different versions of the graphs of f of x equals 2x squared and g of x equals 2 to the x. Notice that the graph of f of x is a parabola, and it's shown in blue on both figures. And the graph of g is exponential growth, which is shown in red on each figure. Notice that each version uses different scales on the axes. On the first figure, the y-scale is 1, whereas on the second figure, the y-scale is 10. Make sure to check each version when answering the following questions. Supply the appropriate inequality symbol. In other words, choose either less than or greater than to fill in the blanks. For part A, as x goes to minus infinity, is f of x less than g of x? Or is f of x greater than g of x? Well, to explore what happens as x goes to minus infinity, we'll want to look at the left-end behavior of each function. For the first figure, we notice that the x values go to -4 on the left. For the second figure, the x values go to -5 on the left. Since -5 is further to the left than -4, we'll use the second figure to answer the question in part A. When we look at the left end of the figure, we notice that the blue graph is above the red graph. Remember that blue represents f and red represents g. So when we pick x values that are decreasing without boundary, we notice that f of x is greater than g of x. Blue is above red, so f of x is greater than g of x. In part B, we're asked to determine whether f of x is less than g of x or f of x is greater than g of x as x goes to positive infinity. So rather than looking at the left-end behavior of each function, we'll look at the right-end behavior of each function. On the first figure, the x values go to 4 on the right end. On the second figure, the x values go to 7. Since 7 is bigger than 4, we'll use figure 2 to answer part B. When we look at the right end of the second figure, we notice that the blue graph is below the red graph. That indicates that f of x is less than g of x as x goes to positive infinity. For part C, we need to determine whether f of x is less than g of x or f of x is greater than g of x when x lies in the interval from negative infinity to -1. The interval from negative infinity to -1 is the interval to the left of x equals -1. So we want to select the figure that allows us to compare the two functions to the left of x equals -1. I'm going to select the second figure. To the left of -1, we see that the blue graph is above the red graph. In other words, f of x is greater than g of x. For part D, we want to determine whether f of x is less than or greater than g of x when x lies in the interval from -0.5 to 1. Between -0.5 and 1, we can see the graph more clearly on figure 1 than on figure 2, so we'll use figure 1 to answer this question. When we look between -0.5 and 1, we notice that the blue graph of f of x is below the red graph of g of x. That indicates that f of x is less than g of x when x lies in the interval from -0.5 to 1. For part E, we want to determine whether f of x is less than or greater than g of x when x lies in the interval from -0.5 to 1. For part E, we want to determine whether f of x is less than or greater than g of x when x lies in the interval from -0.5 to 1. When x lies in the interval from 1 to 6. Well, figure 1 shows us the interval from 1 to 4, but not the interval from 1 to 6. So we'll go ahead and use figure 2. Between 1 and 6, we notice that the graph of f of x in blue is above the graph of g of x in red. Therefore, f of x is greater than g of x when x lies in the interval from 1 to 6. Finally, for part f, we want to determine whether f of x is less than or greater than g of x when x lies in the interval from 7 to infinity. Well, our first figure does not go beyond x equals 7. The second figure does not go beyond x equals 7. However, in the second figure, it appears that when we do go beyond x equals 7, the graph of f of x in blue will remain below the graph of g of x in red. So it would appear that f of x is less than g of x when x lies in the interval from 7 to infinity. To reinforce this, we might use our graphing calculator. Go to y equal to enter f of x and g of x. We'll enter f of x for y1. y1 is equal to 2x squared. We'll enter g of x for y2. So y2 is equal to 2 raised to the x. To differentiate the two functions, we'll change the style of g of x. Move to the left of y2 and press enter to change the style from regular to thick. So the graph of f of x will be regular and the graph of g of x will be thick. Next, we need to create a good viewing window. So let's go to Window, and we want to explore what happens when x lies in the interval from 7 to infinity. So let's select x minimum to be 7. We'll leave x maximum as 10. And rather than selecting values for y min and y maximum, we'll use zoom fit. We see that the regular graph of f is below the thick graph of g, and therefore f of x is less than g of x when x lies in the interval from 7 to infinity.